Every day, reality feels stable and predictable. A ball falls downward. Smoke rises into the air. Planets move around stars in orderly paths. Everything appears to obey invisible rules that never change. For centuries, scientists believed the universe worked like a giant machine. If you understood every force and every movement, you could predict the future perfectly. But deep beneath the world we experience, reality behaves in ways that seem completely impossible. Inside every atom exists a strange microscopic world where particles refuse to follow normal logic. Electrons do not move like tiny planets orbiting a nucleus. Instead, they behave like blurry waves of probability. Scientists cannot even determine the exact position and speed of a particle simultaneously. The more precisely one is measured, the less certain the other becomes. Then things become even stranger. Quantum particles can exist in multiple possible states at the same time. Before measurement, an electron is not simply here or there. According to quantum mechanics, it exists as a spread of possibilities. Reality appears undefined until observation forces a single outcome into existence. This completely shattered the foundations of classical physics. And even Albert Einstein struggled to accept these conclusions. The universe suddenly looked less like a predictable machine and more like something mysterious, unstable, and deeply unsettling. But nothing exposed this terrifying truth more clearly than one experiment that completely changed humanity's understanding of reality forever. In the early 20th century, scientists performed a simple experiment involving particles and two narrow slits. What they discovered shocked. Tiny particles sometimes behaved like solid objects, yet moments later behaved like invisible waves spreading through space. Even more disturbingly, the particles seemed to change their behavior whenever someone attempted to observe them directly. It was as if reality itself knew it was being watched. The double slit experiment begins with something surprisingly simple. Imagine a wall with two narrow openings and a stream of tiny particles fired toward it. Behind the wall is a screen that records where those particles land. At first, everything behaves exactly as expected. For solid objects, they should pass through one slit or the other and form two clear bands on the screen. But when scientists performed the experiment, reality refused to cooperate. Instead of two bands, the screen showed an interference pattern, the same pattern created by waves overlapping in water. This meant each particle was not behaving like a single object. It was behaving like a wave, passing through both slits at the same time and interfering with itself. This alone was already strange enough to challenge classical physics, but then came the real shock. Scientists added a detector to observe which slit each particle actually passed through. The moment observation was introduced, everything changed. The interference pattern disappeared instantly. Now the particles behaved like ordinary solid objects again, producing two simple bands. It was as if the particle knew it was being watched and changed its behavior accordingly. This result shattered one of the most basic assumptions in science. That reality exists independently of observation. And even more disturbing was what this implied. Before measurement, the particle does not choose a single path. Instead, it exists in a state of probability, as if exploring all possible routes at once. Only when observation occurs does it settle into one definite outcome. If physicists were forced to confront a deeply uncomfortable question, does reality actually exist in a fixed state, or does it only become real when it is observed? Some interpretations suggest that the act of measurement collapses infinite possibilities into a single reality. Others propose that every possibility might actually exist in separate branching universes, splitting reality itself into countless versions. Okay. No matter which interpretation is correct, one thing became undeniable: the act of observation is not passive. It appears to be deeply connected to the behavior of the universe itself. And this leads to an even more unsettling question. If observation shapes reality at the smallest scale, what does that say about the nature of reality itself? After the double-slit experiment, quantum physics stopped being just a scientific theory and became a philosophical crisis. Scientists were no longer arguing about small details of atoms. They were arguing about what reality actually is. Okay? Because at the quantum level, the universe refuses to give clear answers. One interpretation suggests that particles do not have definite properties until they are measured. Instead, they exist in a cloud of probabilities, a mixture of all possible outcomes. Reality, in this view, is not fixed. It is fluid, waiting to be defined by interaction. Another interpretation goes even further. It suggests that every possible outcome of a quantum event actually happens, but in separate branches of reality. In this idea, the universe constantly splits into countless parallel versions, each representing a different choice, a different result, a different path of existence. And yet, despite these strange interpretations, quantum physics is not just philosophy. It is one of the most successful scientific theories ever created. It powers lasers, computers, smartphones, and modern electronics. The technology of your everyday life exists because this bizarre microscopic world behaves exactly as predicted. This creates a powerful contradiction. Okay? We can use quantum physics with extreme precision, yet we still do not fully understand what it means. It is as if the universe is giving us correct answers while hiding the true nature of the question itself. At the deepest level, reality seems to resist human intuition. Our brains evolved to understand falling objects, flowing water, and moving animals, not probability clouds and invisible wave functions. So when we try to imagine the quantum world, our intuition begins to fail. This raises a final, unsettling possibility. Maybe reality is not broken. Maybe it is simply far more complex than our minds are built to comprehend. What we call reality could be only a simplified layer of something deeper, something we can calculate but never fully visualize. And if that is true, then quantum physics is not just telling us how particles behave. It is telling us that reality itself may never be fully understood, only observed, measured, and approximated. And that leaves us with one final question that science still cannot answer. If reality changes when it is observed, then what is reality doing when no one is looking?